Good morning, everyone. Welcome to day 2 of Chicago Roboto, live from Denver, Colorado. Hope you had a great first day yesterday. I know all of us did. Welcome, TJ.
Hello.
All right, I'll add your slides. All right, everyone, enjoy your day. Remember, have fun, talk to each other, make sure you meet some new folks via Slack or the networking feature of Hopin. And with that, TJ, take it away.
Thanks, John. Hello, everyone. My name is TJ. I'm a senior Android engineer at Game Changer. And today I'm going to be talking about emotional intelligence and building smarter animations with Kotlin Delegates. So this talk is going to cover quite a bit. But the star of the show really is animations and how Kotlin makes them better. It makes them better in a way that would be, way difficult or way more difficult than it would have been otherwise. So this talk is going to cover a few things. It's going to talk about modern Android architecture. It's going to talk about where animations fit in this world of modern Android architecture. Talk about some core tenets of animation. We talk about how we can actually model animation into our state. And then talk about specifically how Kotlin delegates make all this, possible. And then, just pretty much delegates everywhere, just showing how the delegation pattern is especially powerful and beautiful. And then also a wrap up with a demo where I would actually be showing the animations in real time with this sharing of my phone screen, as well as walking through some code. Okay, with that being said, what we're looking for or what we're hoping to get is how would you create like an Android app where there's all this pieces of UI on the screen, and then for every human interaction, for every tap, like the UI just seems to just shift into place. That's why this, in this particular GIF, this is occurring over 3 different fragments, right? So, but each piece of UI just acts like it was just transformed from one fragment to the next, and it looks like there's nothing, it's just literally, it looks like it's one screen, despite it being different fragments with their own view models or view controllers or what have you. Okay, so first off, let's talk about modern architecture, Android architecture. It's all about unidirectional data flow, right? The phrase has been repeated often and often enough that, it is really easy to manage your UI if your UI is a function of your state. And I'm going to be repeating that ending phrase quite a bit, UI as a function of state. But ultimately, it's all about unidirectional data flow. State management is moved out of the view into some class that controls this, typically a view model if you're using the Jetpack components, but it could be anything. This controller then publishes an object which encapsulates the current state of the app needed to render the view. Interactions with this app, or anything that the user does on the view, or whether you're monitoring some data source from a repository or some database, all these interactions are then just fed into this view model, and then this just churns out new state. This is a graphic I borrowed from Chris Baines. He has a really, really well-written blog post about this. In fact, the phrase emotional intelligence is borrowed from Chris Baines. I'm sorry, not Chris Baines. Shoot, I forget his name. But he's an Android DevRel. But this graphic is borrowed from Nick Butcher. Nick Butcher is his name. This graphic is borrowed from Nick Butcher. And pretty much you just have this view model, and it pushes out different states of a UI model. This UI model representing what the UI ought to look like at any point in time. So where do animations fit in all this? Well, the thing is, the best thing about unidirectional data flow, as we saw in that last GIF, is that it is stateless, right? You just push out, something happens and you have some new state. It just tells you what your new state is. The intermediary states in between don't necessarily matter. It's just that this is your current state and this is now your new state. In some state, the progress bar might be showing. In some other state, the progress bar might not be showing. But the best thing about this is that, the state, once you take a look at the state, that is what the screen should look like at any point in time. It's a snapshot. However, unfortunately, animations are quite stateful, right? Otherwise, if animations weren't stateful, they're just things would just flash in and flash out, and it wouldn't be an animation anymore. For example, if a view is moving from one corner of the screen to another corner of the screen, it has, on that timeline, it has, its translation can change however much it needs to change in that time frame. Things move gradually over a period of time. That's what makes it animate. So this dichotomy makes it really hard to consider animations and makes them more often than not cherries on top of the feature you're trying to deliver rather than a core feature requirement. And personally, it's not, as someone that uses apps, it's not quite nice to see things pop and flash into place. It's always nice it gives this level of cohesion. Things just seem to move organically. Things just seem to make sense. The navigation, Google recently released for the material components, the material shared element transitions to make it easier to communicate to the user that plays within your app, right? You were used to be in one position, whether you're going deeper into a navigation stack that had the Z index navigation that shows you're going deeper into the navigation stack. If you're using a view model, view pager, you tap the next tab, there's a nice little animation that shows you're just looking at another tab in the same window. So all these things, they really, the little things, but they do add up and help for the user to understand the navigation and the placement within your app. So in this case, this is an example of an animation just flashing in and out. Again, this is Berg from Nick Butcher. The login button is there, and then the animation just kind of flashes in and flashes out, and it's not the greatest user experience. Arguably, it's a bad user experience. So to solve this, there's a bit of a systems engineering approach. We can talk about the core tenets of reactive animation, right? Animations need to be reentrant. This means that they should be able to be interrupted and recalled at any time. They also need to be continuous, right? And move at a reasonable frames per second. They have to be smooth. So changes to the animation should not be abrupt, right? They need to be able to change gracefully. Finally, they need to be smooth, hand in hand with continuity, but more like flourishes with deceleration. If you use like a pure linear interpolation to just animate from one thing to another, the whatever it is that's being linearly interpolated will just come to a stop abruptly. It's nicer to have things like it decelerating and just actually move and mimic the real world, the type of animation skeuomorphism, if you will. So you can stack this into a pyramid, just like the food classification pyramid. Again, this is from Nick Butcher. Animations, and this is how they kind of support themselves. It's reentrant and continuous and smooth. You can't get to the top of the pyramid without the base. So how do we do this, right? How can we deliver all these things easily? Well, view property animators have existed in the framework for quite a bit. I think they were introduced with Honeycomb. So that's almost 10 years. They cover some cases, like, for example, if you want to start a new animation, if you use a view property animator based on the view, it'll cancel the currently running animation and start a new one. However, there's a library that is not, I think is woefully underused. It is the dynamic property animation library. And the important thing about dynamic animation libraries is that they are backed by whatever you want them to be, whatever modeling you want it is to use to model your animation. In this case, I'm going to be talking about springs a lot. They're a very good choice because they're backed by a physics model, which aid interoperability and retargeting. In fact, if you look at the constants through it, there's a course in physics or a subject in physics, simple harmonic motion, and this is actually based on them, where you can have the spring and you can damp or over damp or critically damp the spring as much as you like to give you the desired animation effect. And again, it is part of the dynamic animation Jetpack library. So this is a GIF of taken from the Android developers website, where you just pull this little bug droid down, and then it's using a spring, and then it just springs back into place. Unfortunately, well, sometimes bouncing is a little distracting, but the thing about it is if you critically damp the spring, which you can do, right? It's part of what makes a spring, you can do it that it just decelerates and there isn't, and if you critically damp it, there will be no bouncing. So you can pretty much configure your spring to give you exactly what you want, however you want it. So this is gives an example of like, again, this is from Nick Butcher. This is an example of a little box in the middle of the screen. You bump it to the right and you can bump it to the left. And you notice once you try to bump it to the left, if it was already going to the right, it kind of slows down a little bit like the spring force starts to pull back on it, and then it retargets it to its new position. And this is the great part about spring animation. Because it is backed by a physics model, retargeting is trivially simple, and you don't have to, do any of the math yourself. Okay. So how would you, the view property animators, one of the reasons they get so much use is it's because it's extremely easy to use. You just do spring.translation z. Animate, whatever. But with the power of Kotlin extension methods, you can bake spring property animations into the view as though it were a property of the view. And the way we can do this is you create an extension, give it a spring, give it the property that it is you want to animate, give it how stiff you want the spring to be, give it the damping. In this case, it defaults to damping ratio no bouncy, which in simple harmonic motion translates to a critically damped spring. In other words, it'll come, if you translate it to a different position or you move it to a different position, it'll come to rest the quickest it possibly can without ever overshooting its bounds. In other words, it doesn't bounce at all. Start velocity is fine to default that to null, and that will give you a spring animation object. And then this get key is pretty much Android. In an Android, you can use a view kind of like a dictionary or a hash map of sorts, where if you give it a resource tag, you can return something that's tagged unique to that view. This get key will return a key that maps to a specific dynamic animation view property. In this case, it could be your translation, it could be your alpha, it could be what have you. The spring itself, you can get the tag, get the tag of the key as a spring animation. In other words, this uniquely ties a single, there's a one-to-one relationship between a spring and the view. Right, so every time you call view.spring, it will return the existing spring, and this helps us with the retargeting issue we spoke about earlier. And then finally, you give it a spring force, you set the damping ratio, you set the stiffness, you give it a start velocity, and then you return the spring animation. And with this, pretty much you now have a nice extension in Kotlin that lets you tie a single spring to a single view, one-to-one. All right. Now, the dynamic animation library comes with a bunch of properties. Like I said, you could animate the alpha, you could animate translation Y, translation Z, translation X. But more often than not, there's multiple things you may want to animate. And it's really trivially simple to create your own custom property. In this example, I'm going to be showing how there's a class that I use often to animate the padding of a spring, the padding of a view. The type is float property compat. And then when you want to set the value, I just use the extension methods on the view for updating padding, left, right, top, and bottom. And then for a spring, because you need to be able to retarget it, a float property compat has two things. You need to be able to set a value, and you also need to be able to get the current value. So there's a get value, and again, it just returns view.padding left, top, right, and bottom. In fact, there's another method, like if you have something else and you really wanted to animate, there's a nice convenience method in the KTX version of this that is spring animation of, and then you just give it a getter, a custom function that returns a getter that gets the float property, and a custom setter, and you're good to go. So we've covered quite a bit. So therefore, let's actually start building a system that let us do this as often as we want, however we want. So our requirements for this system is our UI state is immutable till a change is published. We like that any changes, any of them whatsoever, are published, and this change can be animated. These animations must follow the three tenets for animation we outlined earlier. And we also like to be dry. We shouldn't copy paste code all over the place. This should be a very nice portable solution. All right, so let's talk about modeling. So the breakdown for this is there's going to be some global UI host. In other words, and when I refer to global UI, these animations, there are a couple of things in Android apps that are common from screen to screen to screen. A couple of these things that are common is typically there's a toolbar or action bar, now a toolbar at the top. This typically has a title. It may have a subtitle. It may have a back button. It may have, menu an actions overflow menu. You may have a flow in action button at the bottom. this floating action button may be able to expand to have text and so on and so forth. So when I talk about global UI, I mean these things are common to an activity from screen to screen to screen. The setup of this is a single activity, because single activity architecture is really big these days. So on the activity level, the toolbar is there, the floating action button is there. And so therefore, the global UI hosts this thing. So you do not duplicate the toolbar in every fragment. You do not duplicate the floating action button in every fragment because it'll be hard to animate it. You need that to be a single source of, single animation, single view you're animating. So the global UI host refers to the activity. This UI host has something called a global UI controller. Now, this global UI controller, pretty much what it exposes your current UI state. And for people that may want to observe it, this is especially useful in the case where you're, at least in our case, we have a couple of screens where a user may be watching. At Game Changer, we have a live video feature, and we have a couple of screens where, like, if you're watching a live video, the user may choose to watch the video in portrait or landscape, and we need to be able to like animate and change the size of the video view dynamically as the user goes through all these motions. So let's talk about this UI state object. What is it? What can we expect to find in it? This right here on screen is a snippet of it. It's actually a lot bigger than this, but this gives you an idea of the things that, the state changes that we may want to animate between. The toolbar may show. It may have a different menu in it. It may have a different title. The floating action button may show. It may be extended. It may have some text in it. The snack bar may be showing. It may also have text in it. The bottom navigation view, which is a staple in Android apps now, may show and may not. And I do want to do a special call out to the system UI. And I'll go into that into more detail on the next slide. But the worst thing, but before I do that, pretty much I just want to represent all this, with the screenshot, right? So on this screen, we have this doggo list fragment. There's a toolbar. It has a title. There's a floating action button. The floating action button has an icon. It has some text. And then you have a bottom navigation view at the bottom. Going into the system UI, one of the worst things that can happen when you're trying to animate something is when you have state changes that you did not request for or you were not expecting. More often than not, this comes from the Android system. There's a couple of things that the Android system does on your behalf for you. For example, when you show the keyboard, it tries to resize your view area to accommodate the keyboard. If the user goes into settings, leaves your app, goes into settings, and they change whether they want to move from the 3-button navigation to gesture navigation, that changes the size of the system UI. You come back and your app has to react to this. The system tries to do all these things for you. If you're trying to create this really precise state machine that is aware of anything that is truly global, this is really annoying. You do not want the system to just change on you. So it's important when modeling your global UI to be able to model the state of the system. So there's this interface, some system UI. It's split into two. It's got some static things that, quote, shouldn't change, although we will find in some cases it does, like the status bar size and the nav bar size. And then things like the dynamic system UI. This is the left inset, top inset, right inset, bottom inset, snack bar height. This insets typically, for example, if the software keyboard is showing, that will bump your bottom inset or wherever it is your software keyboard shows from. And these are things that we need to be aware of in this global UI to be able to animate things properly. Next, in the global UI animations, we have some codependency modeling. And this is where we have this huge blob of state, but the position of the bottom navigation on the screen is dependent on quite a few things. It's dependent on, well, is the bottom nav visible? Is dependent on the navigation bar size, is dependent on the insets, is the keyboard showing, is dependent, and the same thing goes for the floating action button. The floating action button even has more codependencies. It's dependent on if the floating action button is visible. It's dependent on the snack bar height, because we always want to keep the floating action button above the snack bar. It is dependent on if the bottom nav is visible, because if the bottom nav is not visible, it should drop. If it's visible, it should rise. It's also dependent on the bottom inset, i.e. is the keyboard showing. is also dependent on the navbar size. So you can just see pretty much what we're doing here is like we have independent slices of state that are derived from the global state. So anything, if the global state changes, these slices of state would change as well. Moving on from that, I said the worst thing is if the system springs some uninterrupted change on you and you don't know about it. Android, for the window, the activities window, the Decker view, you have these flags that let you control the system UI visibility. I call this particular combination of flags full control system UI flags, because once you set these flags, the Android system will do absolutely nothing on your behalf. You are on your own. This is Android in God mode, if you will. The system will not resize your screen if a keyboard shows. The system is going to draw your UI behind the status bar, behind the navigation bar. You are on your own. Figuring out the size of the status bar and navigation bar is now entirely up to you. It won't do anything. Adjust, if you say, in your activity manifest, keyboard, adjust input mode, whether you go adjust your size, adjust pan, it won't do anything for you. It has no effect. So this is full control. You're in full control of the system, which is something you need to do if you really want to be able to control all the animations yourself. Moving on from that, let's talk about Kotlin delegates then. So we're doing a lot of things. We've told the Android system, do not help us. We're doing it all by ourselves. How do Kotlin delegates, help us manage this state? The important thing is we got to get Swifty, which I kind of liked a lot, but Swifty sounds a lot like Swift, and this is an Android conference, and I don't care much for Swift at the moment, so I'm just gonna X that out. It's all about Kotlin. We're gonna get Crafty, which ironically is Nick Butcher's. I mentioned him a lot. His blog post on this was really good. But yeah, we're gonna get Crafty. So let's talk about GeneralDelegate. We defined a couple of interfaces before. We had a global UI host, we had a global UI controller. We do not want to re-implement these things over and over and over again. All things being equal, what we would like is for there to be one general implementation of it, and all other things defer to this single one implementation. So we can create a class. We'll call it a delegate. It gives you it has some generic bound T, and it returns some type T any, which is really weird because you would wonder, like, why do you have generic types if you're gonna return any? I'll explain that in a second. But importantly, it is a read-only property, which is one of the interfaces from the base Kotlin reflex method that is bundled into Kotlin. You don't have to download the extra Kotlin for reflect dependency for this. But it's a property that will take T and somehow transform T into a global UI host. Some basic login name and extension to log it. And then this is the single method you have to override for the get value for a delegate. So it's going to give you your reference T, and somehow you're going to convert your reference T to a global UI host. Now, to make this as easy and reusable as possible, what it's actually going to do is going to invoke the source method at the top that returns any, and then try to imply and cast it as a global UI host. If it is not a global UI host, it would throw an illegal state exception that this, whatever thing it is not hosted by a global UI host. So how do we actually use this? So this is just a general delegate that lets you take any type T and transform it somehow to a global UI host. The implementation is entirely up to whoever. So how do we use this in a fragment? Well, like I said, the global UI host more often than not is the activity. So if you have a fragment instance, the way you use this delegate is fragment global UI host by that general delegate, and we're going to be getting the activity and casting it. So ultimately, the activity, whatever the activity this fragment is hosting, whatever activity is hosting this fragment must implement the global UI host. So with that said, you can then easily write an extension to give you a val to give you the global UI host, which returns the global UI controller, and that'll give you a live UI state. If you want to make immutable, in other words, if the fragment in reaction to its view model wants to mutate the global UI state, you can then declare a var extension and use a get, set, and pretty much it'll grab its global UI host defined as the delegate at the top, return its UI state, and then to set it, it'll just set the value on it. Really simple. Power of delegation. Somehow, with pure extensions, pure Kotlin extensions, a fragment, for all intents and purposes, is now a global UI controller, because these are the two types in the global UI controller. The global UI controller has a UI state var and a live UI state val. And simply by just delegating to the activity, the fragment is now a de facto global UI controller. Same thing happens if you're in a view. For example, you write a custom view, and this custom view somehow needs to be able to change or mutate the global UI based on some condition. The view is a global UI host. Using that same delegate, it's going to get the context of the view and unwrap the activity. Unwrap activity is simply an extension that every view is backed by an activity, unless it's a remote view. But for most intents and purposes, Android views are backed by an activity. However, this activity may be wrapped by a context theme wrapper, whether it's a backport of older Android versions and so on and so forth. So if you're in a from a view, if you want to get the backing activity, all you have to do is it.context, and in a while loop, check is the context a context theme wrapper. If it is a context theme wrapper, get the base context and check if that is a context theme wrapper. You unwrap this context theme wrapper at some point, and you will eventually, without fail, hit the activity. So the delegate will just grab the context and unwrap the backing activity. And similar to the fragment, you get all these things out of it. Again, similar to the fragment, you can now, a view is now by default implicitly a global UI controller, as long as the activity it's in is a global UI host. Okay. So putting it all together, we've talked about animations. We talked about we want to use Spring animations. We've shown how to do one-to-one linking between a view and its Spring. We've talked about how Kotlin delegates can, implicitly just let you walk up the chain and make a fragment, a view, whatever, that ultimately has a way to get the backing activity. You can make a delegate that makes that type, a default by, just make that type a global UI controller. So putting it all together, let's create the one concrete implementation of this global UI controller. So there's a class. It's a global UI driver. This class is going to be hosted in the activity. It takes two parameters, the activity, or the host, and the binding. And this is just the view binding generated for the layout of that activity. And then this is how you'd use in the activity. The activity is a global UI host, and you can just define it simply. You have a global UI controller by a lazy instantiation of the global UI driver and the binding. So now your activity is a global UI host, your fragment is a global UI controller, your view is a global UI controller by proxy through the activity to this global UI driver. It's a lot of hoops, but it's extremely useful. So let's talk about, I mentioned earlier that we put certain flags in to make sure the Android UI, the Android system cannot spring an unannounced animation on us. But we do need to be able to react to changes in system UI. The way we do this is Android has this really nice class, the onApply Windows Insets Listener, and that will let you know anytime the window instance has changed. So this callback is what we solely depend on. We tell the Android system, don't do anything for us. We want to manage those changes ourselves. And the way we do that is we use the view onApply Windows Inset Listener, and that will give you a Windows Insets class that will tell you the state of the system UI at any point in time. So what we do is, as soon as those insets change, we take our UI state and we reduce those changes in the insets into our system UI. So our global UI state is fully aware of what the system UI looks like at any point in time. And then finally, we also consume them. So because some Android views, like the bar navigation view, like the coordinator layout, like snack bars, they are inset aware. And anytime the insets change, they will try to compensate. And you don't want them to do that. So once we get the insets in, we observe it, and then we consume all the insets so no other views can see it. As far as we're concerned, we are the only ones in control of what the views look like. The system be damned. It should have no influence on this. Moving on. So in the global UI driver, in the constructor, in the init function, we grab the host, the activity window. We set the full control system UI flags. We set the navigation bar color, status bar color to transparent because we want full control over this. And then we, just for insurance, on the root of the activity, so binding.root, we give it the root insets listener. And for insurance, the toolbar, the bottom navigation, content container, we override the default system insets listener that make them system UI aware. Again, we want to be in full control of everything. That said, so we now actually have to start monitoring the slices of our state that map to what things ought to look like. So this is what I've written here is just a couple of infix functions that make it really nice to declare how you want things to look. So it's a bit of syntactic sugar. So there's a method reference. So for every UI state, the slice of UI states that maps to what the float in action buttons, text, and icons should look like, when it's changed, we're going to set the fab glyphs. Same thing for the fab state. Same thing for whether the fab is extended. Same thing for the navigation bar color, status bar color, fragment, container state, so on and so forth. I'm going to zoom in on the update fragment container, though, so you can actually see how we use Spring animations to animate this. But pretty much the global UI driver just takes slices of state, and then for each slice of state that changes, there's a method that is being invoked on its behalf. Update fragment container state looks something like this. This is when you now start taking all those slices of state and start modeling dependent things. The status bar size is, we should include the status bar size if, the state, the system UI has a top inset. In other words, the status bar has insetted. We should also inset it some more if the state says the toolbar is showing. So the toolbar size if the toolbar is showing. And then we cleared the top. And then there's also a couple, I didn't have enough space on the slide, but you can pretty much see that the fragment container positional state is a slice of global UI, and it takes all those things. And ultimately what it does is it uses a Spring, and it uses the custom padding top property, and it'll animate the padding of this fragment container to whatever that value is. In other words, I'm going to shrink the top or shrink the bottom, depending on the state of the system UI and other things. So if the bottom navigation is showing, I'll shrink it some more. If the keyboard is showing, I'll shrink it even more. But this is how we pretty much reduce all that state, and then we just tell the Spring animation to animate to its final position. Very simple, very terse, very concise, and that's all. And this can change how many times as we want. This will always look great. And I'll show examples in a bit. So how do we use it? You could imagine, and again, I'll show this on my phone in a bit. You can imagine in the fragment, this fragment has a bunch of tiles that shift and move up and down. You could just imagine as soon as a view is created, you just want to set some initial state for this fragment. The toolbar is showing. The toolbar has no menu. The float in action button is showing. The bottom navigation is not showing. The float in action button has some text and so on and so forth. But you could just imagine this as like in React, just think of you have a reducer, you send an action that mutates your state and so on. You can just imagine as the action is, you just define the new UI state you want, slam it into the extension method, the var extension extension property earlier, just smash it in there, and everything will animate and look beautiful. Same thing goes for this class, endless tiles. And again, it's really hard to explain this without showing, and I will show you in a bit. But what I did want to outline in this slide is how easy this is to use. You just create a new instance of this data class, tell it everything you want, set it on the delegate property provided earlier, and everything would just work. So this is a GIF showing things in motion. So I'm moving from one fragment to the next. The first fragment has a bottom navigation view. The second fragment does not have a bottom navigation view. So in moving on view created of both of these fragments, I set different UI states. Once I set it, you notice that the float in action button starts animating out because the bottom navigation is going out and in, and everything just kind of like just morphs into place, right? Two completely different states have been published, and the UI just animates cleanly because everything is backed by Spring. I can retarget, tell it where to go. The bottom navigation animates out, the float in action button animates in. It's all very beautiful, and it's simply just because I'm using a physics-backed Spring property. So I've said a lot. I want to show a demo of what these things look like. So permit me to share my screen here a bit. All right. So this is a demo app. This app is open source, is on GitHub, and it's pretty much a playground for all of these. So I am going to go into one of these screens. I'm going to go into doggo rank. I'm going to change the order in which I like my dogs. So I'm just going to make this dog the bottom. And then a snack bar shows, and the global UI knows that the snack bar height has changed, and it will animate the fluid action button in and out. I can do this as many times as I want, regardless of how many permutations. Everything knows where it ought to be. I'm going to do something really complex now. I'm going to jump between a bunch of screens. As I jump between a bunch of screens, everything should just animate properly, because the thing that drives this driver, everything is backed by this single global UI driver, and everything's backed by Spring. So I'm just going to go in here. I'm going to adopt this dog. I'm going to pop out. I'm going to go to this list. I'm going to go to shifting tile. I'm going to hit this a couple of times. I'm going to back out of this. And I just really want to show like the persistence, despite how many fragments I've gone into. Sorry, I use Canary to debug. Pardon the interruption there. So I'm going to go back into the shifting tiles. I'm going to tap a tile. I'm going to pop out. Unfortunately, someone interrupted me again. But that's okay. But that's why I really wanted to emphasize. I wanted to emphasize that the springs can give you so much control, so much so that I am willing to go into our app, our production app at work, and show you this global UI playground. Like I said, we have now full control of everything on the screen. And this works back to API level 21. One of the highlights of the new Android version coming up is being able to animate your UI when the keyboard shows. But with Spring animations, you can actually do this today all the way back to API level 21. I am going to show the keyboard. And then you notice right there that the float in action button animated in response to the keyboard. I can change my keyboard type, and the float in action button knows to drop, because again, we have full control of the system UI flags. Every time the system UI changes, it's reduced into the global UI, and that slice of UI that is, drives the flow in action button is aware of that. I could do, so many permutations, and I can just change it and do whatever I want. In this case, I can even hide the bottom navigation bar, and then it knows that it should, the flow in action button knows it should drop down to that position. I can show the bottom navigation again, and when we don't have internet connection in our app, we have a nice little offline indicator. So if the offline indicator is showing, the flow in action button knows to move out of the way. If I hide the flow in action button, it also knows to get back into the way. And this is pretty much how we model state, on screens that have the flow in action button that do not. We use this global UI to just tell it exactly what we want it to look like. And we can change so much in the app. We can change the toolbar title. This says GC global UI now. I can change it to, I don't know, this is a DJ Khaled ad lib. We're the best, we global. And you can mix and match values for the effects. Pretty much I have the power. And again, I can bring this up, I can take it down. Everything just animates, and we have so much more control over this. For example, on screens where we want to be fully immersive, like we're showing video, we do not want to show the system UI. We do not want to show the bottom nav. I can do, so I'm going to say it is immersive. The system UI is gone. I'm going to bring it back for a second. I'm going to say I have no insets, so I'm drawing all the way behind everything. And I'm going to say it is immersive. And then I'm also going to hide the flow in action button. And you can see I'm drawing. I don't know if you can see the entirety of my screen here. I'm just going to shrink this a little bit. But I am drawing behind the entirety of the UI. So to wrap up, because I'm running out of time here. I'm throwing it back just a little bit. And this is a trigger warning for anyone that's done Android for over 5 or 6 years. Initially, when fragments came, the typical way of implementing interfaces with a fragment is the fragment will have an internal or private value for a callback. The fragment would then, on attach of the fragment, you would then try to grab the fragment and cast it, and cast the type in the activity, cast the activity to the type that you want to pass to the fragment, and then you say fragment dot set on headline selected listener, and you pass the activity in. This is the Java-esque way. You pretty much have to hook into the fragment lifecycle, cast the activity. In this case, if I wanted to set a global UI in the unattached of the fragment, I would have to cast the activity to the global UI host and then set it on the fragment. It worked. It was ugly. It was tedious. One of Kotlin's biggest strengths is how it gets out of your way to get things done. Delegation isn't a new pattern. It's existed in Java, and this is the old classic Java way of doing it. Kotlin just makes it really, really easy to do in a squeaky clean way. There's one implementation of the global UI delegate. Tell it what type that you want to map as a global UI host, and it just works. Lazy delegation, along with read-write properties, are heaven sent for delegation in Android and make for excellent animation drivers and coordinators. So you can, I'm gonna put, there's links to this on my Twitter if you're interested in that sort of thing. That's my Twitter @AdetunjiD. All of this and the sample app for this is open source. It's on GitHub, also at that same handle. The modules that you can use to build this, the Spring animations, extensions, and so on and so forth. If you wanted to be able to just do a Spring animation as simple as view.spring, it's also open source in that Maven repository on GitHub. There's some for core, there's some for Vue, there's some for recycle Vue, and so much more. And that is it. Thank you so much for your time. I hope, next time you think about doing an animation, you will consider using the Spring animation framework for the reasons outlined instead of the Vue property animation framework. The Spring animation framework is beautiful. It is amazing. It does not get enough use. And thank you so much for listening to me go through all of that for about 40 minutes nonstop. Thank you so much for your time.
Awesome. Well done. We've got a question. Don't forget, if you've got any questions for TJ, feel free to throw them in the Slack that's on the bottom of the screen right now. The question we've got right now is, have you noticed any slowdowns or limitations from using the Spring Physics engine on many UI elements at the same time?
That's a great question. No, we have not. None whatsoever. If I'm going to show what our global UI state actually looks like, how big it is in real life. Can you see my screen?
I shared it.
All right, so there's a lot of stuff going on in here. The thing that makes it not slow down is in the implementation of the global UI driver specifically, when we watch all of this, we make sure to make it distinct. So changes will not fire, animations will not fire unless the backend property is different, right? So that's why we have this huge global UI state. And the things that actually react to the animations are slices of that state. And unless a slice of state has changed, no animation will be fired up. So we actually have no slowdowns, no stuttering. Everything is buttery smooth. It works a treat.
Nice. All right, so this is a long one. Philippe asks, with a bigger mental overhead needed to control the entire UI state, even the system UI, how does your team handle the complexity together? Is there a couple of team members whose job is to fix issues with this global UI state? Or does the entire team need to know how to work with it? Is there a cost-benefit trade-off analysis you have to make as a team to maintain and onboard new team members for a complex system like this for more delightful animations?
Right. So that's an excellent question, and this one we actually had to deal with at Game Changer. So global UI state, as it says, it permeates the entirety of the app. So the entire company has to buy into it one way or the other. Everyone is going to work with it. The way we've made this work is everyone is a stakeholder in it, right? One of the issues we initially had was, because this is global UI, this state is shared between all screens, all fragments and stuff. So the initial first implementation of this was we'd have issues where we'd go to another fragment and that fragment will be bringing us state left over from the previous fragment. So if you started the app, the system destroyed your app and recreated it. If you didn't change that slice of state, you'd give you a complete different one than one you were used to before. And this gave a lot of bugs in QA. And the person that actually came up with the best solution for fixing this was engineer that had only been working there for about I think about a year at the time, and his solution was great. He said, look, this is a shared piece of state. Everyone is sharing this piece of state. Whenever you mutate it, be explicit. Instead of pretty much create a brand new data class, and that data class has defaults for a couple of things, so everyone knows what the baseline is. And then every time you set the global UI, make sure you invoke the constructor instead of mutating the existing one. And that just kind of like got rid of all the problems. So like in the slide, when I show using it, is that this is the constructor invocation instead of pretty much, because the initial temptation was to say UI state is equal to the UI state.copy and only change what you want. And that was what was the source of the bugs. By forcing us, instead of reading from the existing state and mutating it, by just giving it a brand new one each time, that just made it really, really, really easy. As far as like, making other people want to use it, our designers can be very crafty when they come up with UI requirements for a screen. They can ask you to do a lot without realizing how difficult that is. The ease of use of the API, because once ignoring the driver, right? Because there's only one implementation, the global UI driver. Ignoring the driver, if you're a developer and you just want to bow to your designer's whim, whenever the designer says, I want this screen to have X, Y, Z, as far as you're concerned, the only thing you need to do is just say UI state is equal to, and just put whatever slice of state maps to your designer's whim. This has actually let us get a lot of features out quicker. For example, one of the biggest features we worked on recently on Android was video streaming, live video streaming, because we power youth sports, and it's very nice for parents to be able to see what the kids are doing in real time. And initially, when you get to that screen, there are no permissions. If you haven't granted permissions, the screen is in portrait. Immediately you grant permissions, we want to force rotate the screen into landscape and start streaming immediately. That's a lot of stuff to deal with, especially if you're a single activity app and you want to manage and change rotation for a fragment. But pretty much in the UI state, we actually have a screen on rotation flag. So immediately the view model says permission has been granted. We just grab the UI state, set it to landscape, the screen auto rotates, we bring up the surface view, and we just start streaming to it directly. So to answer a lot of the question is, everyone has to buy into this. UI, developers, engineers, QA, the whole org has to buy into it. And actually the reason I had that playground where I could show you everything changing was I needed a way to make it easier for people to understand what was going on, so people could go interact and change whatever slice of UI, and they could see how the Spring would react to it. But you do need buy-in, and there's lots of ways you can get buy-in, which is to make the API surface as easy to use as possible and make it easy to visualize and easy to understand, and also demonstrate its robustness, right? This has been shipping for at least 4 months in our app right now, and this is how we coordinate UI, and it's been robust. We do have bugs every now and then, but it's overall worth it. Especially, I think the value prop for it was really demonstrated when we're streaming video. And then, when you stream, when your phone is in landscape, the navigation buttons move from the bottom of the screen, they're now at the right. And now the screen is now inserted on the left and right instead of the top and bottom. And then you don't want your video view to go behind that. So if you could just observe that live UI state, the minute you're in landscape, the view can just change its padding and automatically and we're able to do this in Android in 2 days. iOS, they still have some cards on the board that say like, hey, this piece of, the status bar is jutting into something and stuff. So like, it's one of those things that the initial investment is really difficult, but it really pays off over time, because again, you never have to worry about the Android system doing something you don't want it to do. You're in full control of it.
Gotcha. All right, last question. Tracking all system changes manually seems like a lot of work. Is the system driver / state a general implementation that can be applied to many different apps, or is it generally pretty app and use case specific?
I think it could be generic and you apply it to many apps. I think it'll be easier if I show you what the implementation of that looks like. So pretty much the implementation is, like I said, we have this root insets listener, and every time on apply Windows insets listener gets changed, we just call this method. And then this method, and then after that, we consume the insets. The implementation of this method is fairly straightforward. That's the entirety of it. So you have your Windows insets. By default, we don't want to. So there's two implementations of it. There's the no op one, where you start out, the app hasn't been launched, you don't know what anything is. Implementation for that is top inset, bottom inset, right? Everything is just 0. At that point, you don't know what it is. At some point, that will be fired, typically within a second of startup. And you just want to grab the insets and just start grabbing everything that you want from it. So in other words, window inset top, window inset bottom, Windows inset left, Windows inset right. If you're in landscape, your Windows inset right will now be the status bar height, and so on and so forth. So it's that simple. That is a method that gets called. The Windows inset exposes this, 4 things. I think they've changed it with the new version of Android. They've changed the type of this, so some of these are deprecated or will be deprecated, but ultimately there's still like one-to-one mappings of what to replace it with. But the point being, it is not easy it's not difficult to manage system UI changes yourself. You just grab the slices of state you want from the Windows insets and then just funnel it into the system UI, where again the system UI is just these two interfaces. You just have the status bar size, the nav bar size, and the left inset, top inset, right inset, bottom inset, sidebar height. Those are the only 4 properties. And your bottom inset will change if the keyboard is showing. It will, it will also change if the keyboard is not showing. So answer my question. Fortunately, it wasn't difficult to manage that.
Nice, awesome. All right. Well, that looks like the end of the questions. Remember, if you have any questions that you come up with, the Slack channel is always there. TJ can answer them throughout the rest of the conference. Thank you, TJ, for doing this. That was awesome. Appreciate you being here with us.
Thank you so much. Thanks for having me.
Absolutely. We will be back in about 8 minutes. So stretch, top off your coffees and whatnot, and we will see you in just a little bit.